Recording equipment, on. Video calibration, pass. Audio calibration, pass. Reticulating splines. Warning. Unknown procedure. Date, the 1st of September 2017. Time, 0:07 AM. Temperature, 12 degrees Celsius. Axel, what does reticulating splines mean?
Never mind. I'll tell you later. This is the first of a series of videos on some custom lab equipment. I built this equipment with some priorities that are maybe a bit different from what people normally require. First of all, space. My flat is quite small and my lab room is tiny. So I need to make sure the equipment I build is very compact. Also, obviously, most of these tools, they need to be sort of affordable. Mostly because I don't require a lot of accuracy right now. It's just a small lab I have, and I do this as a hobby, so we'll see how it will be possible in the future to build increasingly more accurate instruments. And usability, they need to work, and they need to work well and as easily as possible. I hate wasting time. The first tool I'm going to show here is a decade resistance box, which is unboxed. So a decade resistance unbox. I will cover a theory of operation, explaining how it works, a list of materials I used if you want to replicate the same circuit, and then maybe a practical demonstration on how easy this is to use and how it works in practice. Anyway, Marian, let's start.
Decade resistance unbox, theory of operation.
Right, so this is a very simple circuit. Let's have a look at the schematics first. So the main feature of this circuit is these 7 columns of resistors going from 1 ohm all the way up to 1 million ohms. And the way you use this tool is by using these female headers to connect to the relative resistance that you need. So for example, given this is the 1 ohm column, it goes from 0 to 9 ohms. If you need 3 ohms, you just connect this header to 1, 2, 3 ohms. If you need 50 ohms, you select the 10 ohm range and you connect this connector to 1, 2, 3, 4, 5 multiplied by 10 is 50 ohms, and so on. Even if I have marked here red and black, it doesn't make any difference. This circuit is non-polarized. It's just because I happen to have red and black connectors and I really like red and black. So let's have a look at the circuit itself now. So these are the connectors. These are the resistors, as you can see. They are columns. And these are the wires with the connectors that allow you to select the resistance. So, for example, we said 3 ohms. So, this is the first column, which is 1 ohm range. So you select 1, 2, 3 ohms. If you need 500 ohms, this 1 ohm, 10 ohm, 500 ohms. You select 1, 2, 3, 4, 500 ohms. And there's not really much more. It's a very simple circuit, as I said. Anyway, Marian, next.
Decade resistance and box, part list.
This is a list of materials, all of the materials actually used in the project. The project is built from this piece of strip board. You can use really any kind of board that you have at hand. I just happen to have several of these strip boards. As you can see on the back, this is the strip board, and we'll have a closer look at that later. The resistors used are some very, very cheap metal film resistors, of the kind that comes in a bunch for very cheap from eBay. Now, these are supposedly 5% resistance. For this specific project, accuracy was not a priority, so it's fine to use these very cheap resistors, but if you need anything more accurate, then you just buy more accurate resistors. Resistors are welded, resistors are soldered. Using this pattern, I soldered one lead of the resistor first, and then bent over the other lead to achieve this sort of zigzagging pattern. Also, I quite like the way it looks. It looks rather neat, almost cute. Almost cute. Connectors. These are just your standard banana jack connectors. The way I installed this is by drilling a couple of holes in the strip board, then mechanically secure the connectors to the strip board, and then solder the electrical connection on a separate tab here, so any mechanical stress will not be transmitted to the circuit board itself. It's probably a bit overkill for this, but I like making things in a nice and tidy way if possible. So and last, the connectors are made out of just normal whatever gauge wire you have, and the male strip header is just your standard header strip, and same thing with the female ones. They are just these standard square connectors with a standard pin inside, square pin inside, which will fit your standard male header connector, like this. That's all there is to it, really. Now we can have a look at how it works in practice. Let's see if I can set up a demonstration for that. Right, Marian, next.
Decade resistance and box, practical example.
So here I set up a very basic circuit to demonstrate how this works. this decade resistance unbox is currently connected to 3 LEDs, as you can see. And they are powered by a 9-volt battery. So let's say you are trying to figure out what's the ideal brightness for those LEDs. You could obviously use a potentiometer if you want, but then you need to use a multimeter to check what the resistance of the potentiometer in that specific position is. Instead, with this is a bit simpler. So let's say, for example, if we use just 1 ohm right now, they are this bright. Whatever brightness your camera and screen, my camera and your screen is showing. So let's focus. Let's say we start with 3 ohms. So 1, 2, 3 ohms. And yeah, they are that bright. But we want them a bit dimmer. So let's say we want to move on to 20 ohms. So first of all, 20 ohms, the 10 ohm range. 1, 2. So this is 20 ohms. And we connect this to the 0. And they are a bit dimmer. But let's go even dimmer than that. Let's say we want 50 ohms. So it's 1, 2, 3, 4, 5. As you can see, they're getting dimmer and dimmer. And let's try instead 100 ohms. So this is the 100 ohms range. And we'll go 100 ohms and short this one to 0. And so on until you reach the desired brightness of the LED. Now, something else I like to use, and the reason why the reason why I like using these jacks is that, for example, I can connect my multimeter like this. Also, you're not a mad scientist if your desk is not very messy and very confusing. So, for example, now we can measure the voltage drop across those resistors if you need that for some reason, which might be useful. Or if it's disconnected and you want a very accurate reading of the resistance, you can just have your multimeter on resistance and read the resistance. As you can see, these resistors are not particularly great, but it doesn't really matter for most of the stuff I work on. And that's pretty much it for this project here. Yeah, Marian, save this report, please.
Procedure completed with warnings. Report saved successfully. Recording equipment off.